Hi, today we're looking at GCSE Maths. We've got the Pearson Edexcel exam board. This is the foundation paper and it's from May 2023. So this is the non-calculator paper. Okay, so question 1. Write 38% as a decimal. Well, I can think of it as money. Think of it as like 38p. How would you write that in pounds? Would it put 0.38? Question 2. What fraction of this shape is shaded? Right, well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. And we've got 1, 2, 3 that is shaded, 3/10. Question 3. Here is a list of numbers. 1.6, 1.4, 2.1, 0.5, 1.3. From the list, write down the smallest number. So we can just look at the whole numbers. These are all 1, 1, 2, 0 and a 1. So that's going to be our smallest. Question 4. Work out -9 plus 5. So let's have a think of a number line. If we've got 0 here, -9 would be down here. If we're going to add on 5, we're going to go to the right. So we're going to go 1, 2, 3, 4, 5. So it'd be -8, -7, -6, -5, -4. Question 5. Solve p minus 2 equals 3. Okay, so we can move the -2 to the other side. So if we move it to the other side, the sign's going to change. It's going to become a +2. So now we've got p equals 3 plus 2, which is 5. Question 6. Freddie adds labels to this diagram of a circle. Explain why one of the labels is wrong. Okay, well, circumference is around the outside, that's good. Centre, looks like it's in the centre. Diameter, well, this isn't the diameter. The diameter would be going all the way across from side to side. In fact, what they have written is what they have labelled as diameter is the radius, however you want to word that. Okay, question 7. Write down 3 different factors of 20. Okay, well, I'm going to write all the factors down up here. Think of them in factor pairs. So you'd have 1 and 20, because 1 times 20 is 20. You'd have 2 and 10, and you'd have 4 and 5. Because 2 times 10 is 20, 4 times 5 is 20. So you can pick any of these 3 factors. I'll go for 1, 2, and 20. Question 8. Work out the size of the angle marked X. Okay, well, the total of the angles around a point are 360 degrees. So if we take off this bit, whatever's left will be the angle X. So 0 minus 0 is 0, 6 minus 5 is 1, 3 minus nothing is still 3. We've got 310 degrees. Now we've got, the student says, this is part B, the student says that an angle of 50 degrees is an obtuse angle. The student is wrong. Explain why. Well, if it's 50 degrees, it's going to be something like that. Well, this would be an acute angle. For it to be obtuse, the angle needs to be bigger than a right angle. And actually we can sort of do a sort of dotted, that would be our right angle in there. Okay, so the student is wrong, explain why. An obtuse angle needs to be more than 90 degrees. It also needs to be less than 180, but the reason that they're wrong is it needs to be more than 90. Okay, question 9. So we've got a line here connecting 2 points, A and B. First part of this question, write down the coordinates of point B. So let's find B. So we want the x coordinate first, so it's going to be 5. Put a line down, and then we're going to go across to 2. So the coordinates for B are 5, 2. Okay, part B. Plot the point with coordinates 4, minus 2. Right, so we're going to go across to 4, and then minus 2 is down here. So we're going to go there, and they asked us to label it with a C. Now part C. Write down the coordinates of the midpoint of AB. Right, so what I'm going to do with AB, give my ruler, I'm going to make this a triangle. And the reason I'm going to do that is because if I want the midpoint, I can say, well, this triangle is 2 boxes high. So half of 2 is 1. Okay, so we're going to use here. Now, if we look across, we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 boxes across, half of 8 is 4. So we've got 1, 2, 3, 4. So if we do a line up from 4, which is halfway across, and we do a line from here, which is halfway up. Oh, could be straighter. Where they cross is going to be there. So we looked at the middle of the way horizontally and middle of the way vertically. Where they cross, that's going to be the midpoint of the whole line. So this coordinate, if we look down, we've got 1 for the x coordinate here. Go across, we've got 3 for the y coordinate. So that's 1, 3. And the final part. Draw the line with equation y equals minus 4. Okay, so this is our y-axis up here. Minus 4, well actually minus 4 is going to be here. So we want all of the points where y is minus 4. So it'll be here, be here, be here, here, here. So in fact, the line of y equals minus 4 is just a horizontal line going across like that. And we can label it y equals minus 4. Question 10. Max sees this special offer in a shop. Buy 1 large plate and get 1 small plate for half the normal price. The normal price of a large plate is £2. The normal price of a small plate is 80p. So we're going to get the small plates for half the normal price. Max wants to buy 6 large plates and 6 small plates using this offer. He has £15. Has Max got enough money? Right, so we're going to want 6 large plates, which is fine. We know the price of a large plate, and 6 small plates. But the small plates, we're going to get them at half price. So before I start, I'm just going to divide this by 2. Half of 80, well, that's going to be 40p. If you want, you can do it with the bus stop method. 2 goes into 8 4 times, 2 into 0, 0 times. Okay, so now what we want is, we want 6 lots of £2 for the large plates, which gives us £12. And then we're going to want 6 lots of 40p. So 6 times 40. Well, we can do 6 times 4. So 4, 8, 12, 16, 20, 24. And then put the 0 on. So 240p. But we want that in pounds, so we're going to move the decimal point twice. So we get £2.40. Okay. So if we want the total of these, so we're going to have 12 plus £2.40, and I'm going to put some zeros in here so we've got something to add together. So 0 plus 0 is 0, 0 plus 4 is 4, decimal point, 2 plus 2 is 4, 1 plus nothing is 1. So we've got a total cost of £14.40. That is less than £15. So has Max got enough money? Yes. I've got enough money. And there's a 4-mark question there. Question 11. A total of 700 tickets were on sale for a football match. 452 of the tickets were sold. How many tickets were not sold? We can take the 700 and subtract 452. If you want to count up from 452 instead, it's absolutely fine. I'm going to do it as a subtraction now. So I'll say we can't take 2 away from 0. So we want to increase this 0. We can't take anything from here. So we're going to reduce this 7 by 1 and pass it over. So we've now got 10 here. We'll reduce the 10 to 9 and give 1 over here. So now we've got 10 minus 2, which is 8. 9 minus 5, which is 4. 6 minus 4, which is 2. So we've got 248 tickets not sold. Okay. Now we're told for a different football match, 297 tickets were sold for £9.50 each. 399 tickets were sold for £19.50 each. Work out an estimate for the total amount of money paid for these tickets. You must show all of your working. So the key thing here is an estimate. So we can do some rounding here. So 297, well, I'm going to say that's approximately equal to 300. And 399, well, that's approximately equal to 400. Now with the price, £9.50, that's approximately £10, and £19.50. We'll round that to £20. So we've got 300 tickets at £10. So we can ignore the zeros, do 3 times 1, which is just 3, and then add 1, 2, 3 zeros. So we've got £3,000 for those. Then we've got 400 tickets at £20. So again, we can ignore the zeros. 4 times 2, or 2 times 4 is 8. And then we've got 1, 2, 3 zeros. Right, we want the total of these. So add them up. 0 and 0 is 0. Same again and again. 3 plus 8. We've got £11,000. With the part C, is your answer to part B an underestimate or an overestimate? Give a reason for your answer. Well, let's have a look back at all the rounding that we did. Well, all of these we rounded up. So everything we do is going to be bigger than it is in real life. Maybe not a lot, but a bit bigger. So it's going to be an overestimate as all the values were rounded up. Okay. Question 12. Here are 6 numbers. Work out the mean. Well, the mean is the total divided by the frequency. So what's the total here? We could write them as a column, but I'm just going to do them in order. 13 plus 5 is 18, plus 4 is 22, plus 9 is 31, plus 3 is 34, plus 8 is 42. So if you want to write them in a different way or try and group the numbers together to make it easy to add up, that's absolutely fine. And the frequency, well, we've got 1, 2, 3, 4, 5, 6. In fact, they tell us we've got 6. So what's the mean? Well, let's start going up in our 6 times table. So we've got 6, 12, 18, 24, 30, 36, 42. So that's exactly 7. Okay. Question 13. Got some algebra now. So simplify 15a over 3. Well, we can just look at the numbers part. We've got 15 divided by 3. So 3, 6, 9, 12, 15. So that's going to be 5. And we've still got the a. So just 5a. Okay, so simplify 19 plus 5b plus 4c minus 7b plus c. So let's look at all just the number bits first. So 19 is the only number that's on its own, that's not with a letter. So we can just keep the 19. Cross that off. Now what about b's? We've got 5b here and minus 7b. So if we think we got number line, we've got 0 here, 5 would be up here, and we're taking off 7. Well, just to get to 0, we're going to have to take off 5. Now, for 7, we're going to need to take off another 2. So that would be minus 1, minus 2. So we've got minus 2b. That's the b's dealt with. And we've got plus 4c plus another c. So that's going to be plus 5c. Okay, and part C, factorise 8d minus 6. So we're looking for common factors. Well, 8 and 6 are both even numbers, so we know that 2 can come out. So if we put 2 on the outside, how many times does 2 go into 8? 2, 4, 6, 8, that's 4 times. And how many times does 2 go into 6? 2, 4, 6, that's 3 times. So we can check, because 2 times 4 is 8, so we'd get 8d if we multiply this out, and 2 times minus 3 would be minus 6. Question 14. Last week, 73% of the tickets sold at a cinema were adult tickets. What percentage of the tickets sold were not adult tickets? Okay, well, we want to know the not adult tickets. So in other words, in total, we're going to have 100% of tickets. If we take off 73, it's going to tell us how many were not adult tickets. So again, you could count up from this one, or we can do it this way as a subtraction. Can't take 3 away from 0. So we've got to go all the way to this 0, reduce it by 1, make this 10. Reduce that by 1 to 9, and make this 10. So we've now got 10 minus 3 is 7. 9 minus 7 is 2. Give us 27%. So if you wanted, you could start from 73 and say, how many do I need to get up to 80? That would be 7. And then how many to get up to 100? Well, that would be 20. You get you 27. Okay. Some people watched a film at the cinema. The number of adults to the number of children was 2 to 5. What fraction of these people were adults? like to think of this as a little ratio table. So we've got adults, children, and we'd have a total. So we've got 2 adults for every 5 children. So in total, we would have 7. So adults is going to be 2 out of 7, or 2 sevenths. On Friday, 500 people watched a film at the cinema. 70% of these people were children. On Saturday, 720 people watched the film at the cinema. 5/8 of these people were children. Kasim thinks more children watched the film on Friday than on Saturday. Is Kasim correct? You must show how you got your answer. And there are 3 marks for this question. So we need to work out the number of children that saw each film and then compare them. So we want 70% of 500. But I'm going to start off by working out 10% of 500. Because I know I can just take a 0 off. And that's going to be 50. So if I want 70% of 500, well, I'm just going to multiply that by 7. 7 times 0 is 0. 7 times 5, 5, 10, 15, 20, 25, 30, 35. So we've got 350 children. Now Saturday, 720 people watched the film. 5/8 of these were children. Well, let's work out 1/8 first of all. So we're going to do 720 divided by 8. 8 into 7 doesn't go, because 8's bigger than 7. What about 8 into 72? Well, let's try. 8, 16, 24, 32, 40, 48, 56, 64, 72. That's 9 times exactly. And 8 into 0 goes 0 times. So 1/8 is 90. We want 5/8. So we want 5 lots. So 5 times 0 is 0. 5 times 9, 9, 18, 27, 36, 45. Okay, so we've got 350 on Friday, 450 on Saturday. We can say 450 is greater than 350. So Kasim thinks more children watched the film on Friday than on Saturday. Is Kasim correct? No. Only 350 watched it on Friday, 450 watched on Saturday. Question 15. Work out 6/7 times 5/12. Give your answer as a fraction in its simplest form. Okay, so I'm going to show you 2 ways to do this. One way, well, with fractions, we can just multiply the top and bottom together. So we can do 6 times 5, which is 5, 10, 15, 20, 25, 30 for the numerator, and 7 times 12, 12, 24, 36, 48, 60, 72, 84. Okay, and then we can simplify this because they want the answer in its simplest form. So we can say, well, they're both divisible by 2. Let's divide top and bottom by 2. And if we did that, we'd get 2 into 3 goes once, remainder 1, 2 into 10 goes 5. So we get 15 on the top. And if we do the same with 2 into 84, 2 into 8 goes 4 times, 2 into 4 goes twice. So we get 15 over 42. Then we say, well, can we simplify it any further? Well, it looks like 3 might go into both of them. So divide top and bottom by 3. So we've got 3, 6, 9, 12, 15. So it goes 5 into the top. And 3 into 42. 3 into 4 goes 1, remainder 1. 3 into 12 goes 4 times. So we get down to 5 over 14. Okay, which we can write down here. Now, I think there's an easier way to do this. And what we can do is we can look at how we can cancel or make these fractions a bit nicer. Now, I can see the 6 and the 12, and 6 is half of 12. So what I'm going to do is say, well, let's rewrite this. instead of, well, we'll keep the 6 and the 5 on top, but we can just swap the order because we're just multiplying these together. So now we've got 6 over 12 times 5 over 7. Looks the same thing, but 6 is half of 12. So in other words, it's 1/2 times 5/7. 1 times 5 is 5, 2 times 7 is 14, which is what we've got here. So this is an alternative, but I think it's simpler this way because you don't have to do all of this work afterwards. So where possible, you can change the order. Because remember, it's 6 times 5 or it's 5 times 6. And the bottom 7 times 12 or 12 times 7. So it doesn't matter if you change those orders. You're not messing up your order of operations or the calculation at all. Question 16. Here is the list of ingredients for making 20 biscuits. So ingredients for 20 biscuits: 150 grams of butter, 100 grams of sugar, 250 grams of flour. Harry wants to make 60 biscuits. How much flour does Harry need? So you could work out how much flour you need for one biscuit and then multiply it by 60. But we should be looking for shortcuts. We want to go from 20 up to 60. So hopefully we'll notice that there's a bit of a pattern. And we can think, well, what about counting in 20s? We'd have 20, 40, 60. So in other words, what we're saying is 60. Oh, not times. 60 equals 3 lots of 20. So that means we're going to need 3 times as much flour. 250 times 3. 3 times 0 is 0. 3 times 5, we've got 5, 10, 15. 3 times 2, 2, 4, 6, add the 1, 7. So we get a total of 750 grams. Question 17. There are 200 counters in a bag. 38 counters are red, 52 counters are blue. The rest of the counters are yellow or green. There are the same number of yellow counters as green counters. What percentage of the counters in the bag are yellow? Okay, I'm going to do a little bit of a table for this. So we've got red, blue, yellow, green. Actually, let's do a total here as well. We know our total is going to be 200. And we've got 38 red ones and 52 blue ones. So, how many have we got here? What's 38 and 52? 8 plus 2 is 10. 3 plus 5 is 8. Plus 1 is 9. So we've got 90 here. Okay, so how many of the yellow and green added together going to be? So we've got a 200 minus 90. 0 minus 0 is 0. Can't take 9 away from 0. Let's reduce the 2 by 1. Make this 10 minus 9 is 1. 1 minus nothing is 1. So these two added together need to be 110. There's the same number of yellow counters as green counters, so we can just divide the 110 by 2. 2 into 1, can't do. 2 into 11, 2, 4, 6, 8, 10. That's 5 times, remainder 1. 2 into 10, well, we just saw 2 into 10 goes 5 times. So we've got 55 yellows and 55 greens. We want the percentage of the counters in the bag that are yellow. So we've got 55 yellows out of 200. To make it a percentage, we're going to multiply it by 100. So we can cancel a 0 and a 0, another 0 and another 0. So we've got 55 times 1, so just 55, divided by 2. So 55 divided by 2. 2 goes into 5 twice, remainder 1. 2 into 15 goes 2, 4, 6, 8, 10, 12, 14, 16 would be too many, so 7 times, remainder 1. Okay, so we can put a 0.0, so we've got somewhere to put our remainder. Put this little point at the top, and 2 into 10, 2, 4, 6, 8, 10, that's 5. So we get an answer here of 27.5%. And it's fine for it to be a decimal because it's a percent. It's not a number of counters. Obviously, we'd only be able to have a whole number of counters, but it's okay for the percent. Okay. Question 18. This is a 3-mark question. Naomi has B bags of apples and C crates of apples. There are 5 apples in each bag. There are 20 apples in each crate. Naomi has a total of T apples. Write a formula for T in terms of B and C. And that sounds much more complicated than it is. So write a formula for T. So in other words, the total number of apples is going to be T equals something. Okay, well, we've got 5 apples in each bag. And we've got B bags. So it's going to be 5 times B. Because it's algebra, we don't need to put the times in. We can just put 5B. That's dealt with the 5 apples with the bags. And the crates, well, we've got 28 apples in each crate. So we're going to add those on. So 20 apples in each of C crates. So it'd be 28 times C. It's just we just don't know how many crates there are. So that's why we leave the letter. And that's it. Nice and straightforward when you know what you're doing. Question 19. Here are the first 5 terms of an arithmetic sequence. -5, 3, 11, 19, 27. Find an expression in terms of n for the nth term of this sequence. So arithmetic means we're adding the same amount on each time, or taking the same amount off. So rather than starting from the -5 to go up to the 3, just because I'm going to avoid negative numbers just to make it a bit easier. Let's start from the 3. So what's the difference between 3 and 11? Well, I'm just going to count. So from 3 it'd be 4, 5, 6, 7, 8, 9, 10, 11. That's the difference of 8. And from 11 to 19, we've got 12, 13, 14, 15, 16, 17, 18, 19. Yeah, so we're just adding 8 each time. We can do the same here. It's going to give the same answer. And even if we counted from the negative, from -5, we'd have -4, -3, -2, -1, 0, 1, 2, 3. So it's adding 8 each time. But we want an expression in terms of n for the nth term of this sequence. So if we think this is the first term, that's the second, that's the third, that's the fourth, that's the fifth. So if we just knew this number, how could we work out what the answer is? Well, because we're adding on 8 each time, we know that it's going to have to do with 8 lots of whatever this number is. So, in other words, 8n. Okay. Now, so this is going to be my n's. And I'm going to do an extra sort of row down here. So if we did just 8 times n, we'd have 8 times 1 is 8. 2 times 8 would be 16. 3 times 8 would be 8, 16, 24. Add another 8 would be 32. Add another 8 would be 40. Okay, so we've got to think, well, how are we getting from these numbers to these numbers. So from 8 down to minus 5, or 16 to 3. All of these, because it should be the same rule each time. I'm going to start with the 16 to 3. So if we do 16 minus 3 to find the difference, 6 minus 3 is 3, 1 minus nothing is 1. So what we're doing is we're multiplying n by 8, so that 8n gives us a 16, and then we're taking off 13. So we can try this with any of them. Let's go for the end one. 40, which was our 8 times 5 to give us 40. And then if we do 40 and take off 13, 3 from 0 we can't do, so reduce that by 1 and make that 10 minus 3 is 7. 3 minus 1 is 2. So 27, yeah, that's what we want. So the answer we've got is 8n minus 13. So we start off by finding the difference, multiply that by your n, and then see what number you need to adjust, either to make it bigger or to make it smaller, so that you can get back to the sequence you started with. Okay, question 20. Actually, we just got a big space there, but we've got 3 marks for this question. So 8.46 divided by 0.15. Right, so what I'm going to do is I'm going to ignore the decimal points for now, and just say, well, let's think of that as 846 divided by 15. Okay. In fact, let's write that as a fraction. And the reason I'm writing it as a fraction is because then we can look at it and think, well, can we simplify this? Have we got any common factors? Well, I know that the factors are 15. Well, we've got 1. That's not going to help. We've got 15. Well, that's not going to help because that doesn't end in a 5. We've got 3 and we've got 5. So again, 5 won't go into 846, but 3 might. And I know 3 goes into 15. So let's see if we can divide 846 by 3. So 3 goes into 8, 3, 6, that's twice with 2 remainder. 3 into 24, 3, 6, 9, 12, 15, 18, 21, 24. That's 8 times. And 3 into 6 goes twice. Right, so we can divide top and bottom by 3. So we can simplify this to 282. And 3 into 15 goes 5 times. Now we've got 282 divided by 5. We can do that as a bus stop method. So 5 into 2 doesn't go. 5 into 28. 5, 10, 15, 20, 25. That's 5 times. Remainder 3. 5 into 32. 5, 10, 15, 20, 25, 30. 6 times. Remainder 2. So we're going to do a 0.0. So we've got somewhere to carry the 2. 5 into 20. 5, 10, 15, 20, 4. So we've got an answer of 56.4. But if you remember, we had 2 decimal places, 2 decimal places. But because, let's show, if you think of this as a fraction, we wouldn't normally have decimals written as fractions, but if we had written it like this, you'd see, well, to get from here to here, effectively we've moved the decimal point twice to the right on the top and twice to the right on the bottom. So it's like we've multiplied both by 100. So this is exactly equal to this, which is equal to this. So the answer here is in fact the final answer for the question. And we can leave it like that. So essentially we've multiplied top and bottom by 100 to get rid of the decimals. We've then simplified the fraction, so it's then easier to do the division down here. Question 21. Work out 7 3/8 minus 2.5. Give your answer as a mixed number. Right, so I'm going to convert both of these fractions into mixed numbers. I think that's going to be easier for me. So 7 3/8. The way we do that is we multiply the whole number by the denominator. So 7 eighths, so 8, 16, 24, 32, 40, 48, 56. And then add on the 3 for 59 eighths. So I'll write it here. So we did 7 times 8 and then added on the 3. And we've got minus, instead of 2.5, we're going to do 2 times the 2 at the bottom and then add on the 1. So we end up with 5 halves. Now if you're adding or subtracting fractions, we need the denominators to be the same. They're not the same at the moment, but 2 goes into 8 and it goes into it 4 times. So what we can do is say, well, keep the 59 divided by 8, and this one, we want it to be over 8, which means we're multiplying the top and the bottom by 4. So 2 times 4 gives us the 8. 5 times 4, 5, 10, 15, 20. So these two are equivalent fractions. 5 halves or 20 eighths. So the answer is all going to be in eighths. So we've got 59 minus 20. 9 minus 0 is still 9. 5 minus 2 is 3. So we've got 39 eighths. But they want the answer as a mixed number. So we want to know how many times does 8 go into 39. So we've got 8, 16, 24, 32, 40 would be too many. So 32, so it goes in 4 times. And from 32, we've got 33, 34, 35, 36, 37, 38, 39. So that's 7 remainder. So that's 4 7/8. Okay, question 22. Now, this is a type of question that comes up quite often. This one, a cube has a total surface area of 150 centimetres squared. Work out the volume of the cube. Right, well, I'm going to do a sketch of a cube first of all, so we can think of a cube. We've got a square front, square top, square sides. Okay, and if we make it a bit more sort of 3D, we'll see we've got top and a bottom, 2 sides, back and front. So we've got 6 faces on this cube. In fact, what we can do is we can do a quick sketch of the net of the cube. So if we flatten this out, this is what it would look like, because we're talking about this total surface area. So it's saying if we work out the area of all of these and add them together, we're going to get 150 centimetres squared. Now you might be thinking, well, how's that going to help us to work out the volume of the cube? Well, I know that the volume of a cube, well, if it's a volume of a cuboid, it's length times width times height. Because it's a cube, all of those are the same. So let's say the length is x. Well, it's going to be x times x times x, or x cubed. So that would be x, that would be x, that would be x. So if we can work out what x is on here, any of these lengths, they're all going to be the same, then we can work out the volume. So we know these are all squares. They might look like rectangles on my sketch, but we know that they're squares. All 6 of them are 150 centimetres squared. So why don't we divide 150 by 6. So we can just worry about one square. Well, 6 into 1 doesn't go. 6 into 15, 6, 12, goes twice, remainder 3. 6 into 30, 6, 12, 18, 24, 30, goes 5 times. So 1 square is 25 centimetres squared. Now, we know that the area is the length times the width. And we said in this case the length and the width is x. So basically x squared is 25. So 1x is going to be the square root of 25. So what number, when you multiply it by itself, gives you 25? And you can write down your square numbers. So we'd have 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Right, so square root of 25 is 5. So we know what x is. So we want 5 times 5 times 5. And we already saw that 5 times 5 is 25. So basically we want to work out 25 times 5. As we saw before, 5 times 5 is 25. 2 times 5 is 10, plus 2 is 12. So our volume is going to be 125 centimetres cubed. And that's for 4 marks. And so you get this question quite often, and they can ask it the other way round, so they could give you the volume and ask you to work out the surface area. And what you need to do is work out what one length is first, and then you can take it from there. Question 23. The table shows information about the daily rainfall in a town for 60 days. So there were 4 days where there was between 0 and 5 millimetres of rain, 24 days where there was between 5 and 10 millimetres, 13 days where there was between 10 and 15 millimetres, 11 days where there was between 15 and 20 millimetres, and 4 days where there was between 20 and 25 millimetres of rain. Draw a frequency polygon for this information. Right, so with a frequency polygon, what we're interested in is the midpoint of these. So what's halfway through the range? Well, 0 and 5, well, if we want halfway, we're going to add them together. So 0 and 5 would be 5. And divide it by 2 to find the midpoint. Well, 5 divided by 2, you can do it with the bus stop method, but hopefully you'll see that that's going to be 2.5. And similarly, halfway between 5 and 10 is going to be 7.5. Put midpoint. So between 15 and 20, 10 and 15, it would be 12.5, 17.5, and halfway would be 22.5. So for the polygon, if we look at the first value, we've got a midpoint of 2.5 and a frequency of 8. Even if you're not totally comfortable working out those midpoints, you can just think, well, it's going to be halfway between them, so it's going to be here. And we've got a frequency of 8. So 1, 2, 3, 4, 5, 6, 7, 8. So just put across there. So maybe I've overcomplicated it with the midpoints, but it's good to know that's what you're doing. So we want the midpoint of this range with a frequency of 24. So halfway between would be on this line. 20, 21, 22, 23, 24. For the next between 10 and 15, we've got 13. 10, 11, 12, 13. Then between 15 and 20, we've got 11. 10, 11. Between 20 and 25, we've got 4. 1, 2, 3, 4. Then for frequency polygon, it's a bit like a line graph. We join our points together with a straight line between each point next to each other. And there we go. Question 24. Okay, so we've got a set of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and we're told that A is the odd numbers and B are square numbers. Complete the Venn diagram for this information. Right, well, odd numbers. Odd numbers would be 1, 3, 5, 7 and 9. Square numbers, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, so that's out of the range. So these are the only ones we're interested in. So I'm going to start off by putting any numbers that I think are both odd and square. So we've got 1 is in both sets, so we can put that in there. And 9 is in both sets, so we can also put that in there. Now, have we got any odd numbers that aren't squares? Well, we've got 3, 5 and 7. So they can go here. So I'll cross them off. We've used 1, we've used 9, we've used 3, 5 and 7. So that's those. And we've got the number 4, which is a square number, but not odd. We'll cross off 4. So anything left is going to have to go in here. It doesn't fit into either of these. So we've got 2, 6, 8 and 10. And so we write them there. And then we're told a number is chosen at random from the universal set. Find the probability that this number is in the set B dash. Well, B dash means not B. Well, we know we've got 10 numbers in total. So if it's not in B, well, we've got 1, 2, 3 numbers that are in B. So the ones not in B are going to be 1, 2, 3, 4, 5, 6, 7. So we're going to have 7 tenths. Question 25. The scatter graph shows information about the ages and weights of some babies. Okay, so we've got weight going up here and age going here. Okay. And the first part says, describe the relationship between the age and the weight of the babies. Well, there's quite a clear pattern here, I'd say. As the age goes up, the weight goes up. And we can just write that. As the age increases, so does the weight. Or you could say there is a positive correlation. One goes up while the other one goes up. Another baby has a weight of 5.8 kilograms. Using the scatter graph, find an estimate for the age of this baby. Right. With the graph as it is, that's difficult to do. So what we need to do is draw a line of best fit. So this is a straight line using a ruler that goes through the data, following the overall pattern, and we want, so it's going to be this sort of gradient. We want roughly the same number of points above the line as below the line. So I'm saying something. It doesn't matter if the ruler goes through a line or not. So it goes through a point or not. That looks about right to me. Actually, I'm going through some there, but I don't need to. So we're interested in a baby that weighs 5.8 kilograms. So 4 and 6, so 5 would be in the middle. Now we've got to be careful here, because if we look, if this is 5, they're not going up by 0.1 each time. We've got 1, 2, 3, 4, 5 squares here for 1 kilogram. Okay, so we're going to be going up in 2, so we'd have 5.2, 5.4, 5.6, 5.8. So we want to, so this is our 5.8. So we're going to draw a line across and see where it hits our line of best fit, which is here. And that comes down to about here. So again, if this is 2 and 4, 3 is going to be in the middle. So these are going to be 3.2, 3.4, 3.6. So we're going to say, oh, sorry, you can't see that on there. So I drew my line across, came down, said between 2 and 4 is 3. And then each of these little squares must be worth 0.2. So 0.2, 0.4, 0.6. This must be 3.8 for us to get to 4. So our estimate for the age is going to be 3.8 months. Your line of best fit isn't going to be exactly the same as mine, so that's fine. So if you get a slightly different weight, not a problem, as long as it should be close to the 3.8 or 4 that I got. Question 26. The price of a holiday increases by 20%. This 20% increase adds £240 to the price of the holiday. Work out the price of the holiday before the increase. Okay, so £240 represents 20%. What I'm going to do, because I find it easier to work in tens, so I'm going to say, well, if we half that, so it's 240 divided by 2. 22 goes once, 24 goes twice, 20 is 0. So half of 240 is 120. And half of 20 is 10. Now, if I've got 10%, I want to go back to the original amount, which would be 100%. And I know to get from 10% to 100%, I multiply by 10. So we just need to do the same here. And if we multiply by 10, we just put a 0 on the end. So the original price was £1,200. Question 27. This is a 3-mark question. The diagram shows a solid cylinder on a horizontal floor. We've got our cylinder here. We're told it's 40 centimetres tall. We've got a formula here as well. The cylinder has a volume of 1,200 centimetres cubed and a height of 40 centimetres. The cylinder exerts a force of 90 newtons on the floor. Work out the pressure on the floor due to the cylinder. Well, we're told the pressure is the force divided by the area. The force is fine, they've already told us that, it's 90. So we need to work out what the area is. Now I know that the volume of a cylinder is equal to the area of the circle times the height. So we know that this 1,200 equals the area times 40. So if we rearrange this, in other words, if we move the 40 over, so we're going to divide by 40. And let's do that over here. 1,200 divided by 40, cancel a 0, which makes it 120 divided by 4. 4 into 1 doesn't go. 4 into 12 goes 3 times. 4 into 0 is 0. So we end up with the area is equal to 30 centimetres squared. Right, and that's what we're after. So we know the pressure is the force of 90 divided by 30. Cancel our zeros. We've just got 9 divided by 3, which is 3. So you still need to know how to rearrange it, but what looks like a pretty awful question actually isn't too bad if you start to just put things in the formula. Obviously we do need to use this, but I don't think that's too bad at all for 3 marks. And we can just write 3 down here. Okay, question 28. We've got 2 graphs on here. We can, 2 lines on here. We've got 2y equals 3x minus 22 is this line here, and 2 minus 2y equals x is this one here. And we're told use these graphs to solve the simultaneous equations. So use these graphs. So don't use algebra, just use the graphs. So much more straightforward than you might think. Where do they cross? That must be the solution. So we go up to here. 5, 6. So this is 6 on the x-axis. And on the y-axis, that's minus 5, that's 0, so minus 1, minus 2. So the solution is x is 6 and y is minus 2. Okay, question 29. Work out the value of 4 to the power minus 6 times 4 to the power 9, all divided by 4. I'm actually going to write this 4 as 4 to the power 1, because that's what it is. Then at least we've got powers on all of them, a bit easier to understand. So 4 to the minus 6 times 4 to the 9. Well, when you've got 2 numbers you're multiplying together, but with different powers, you add the powers. So we want minus 6 plus 9. Well, if we think of a number line, minus 6 would be down here. So we'd need to add 6 to get to 0. And then we'd need, from 6 we'd need 7, 8, 9. So we'd need to add another 3 more to take us up to positive 3. So that's going to be 4 to the power 3, or 4 cubed, divided by 4 to the power 1. Okay. So if we cancel, we've got 1 power here, so we can cancel the 4 here, reduce that by 1. We end up with just 4 squared, which is 4 times 4, which is 16. Just to show you how I did this cancel thing, if you think 4 cubed over 4 to the power 1 is 4 times 4 times 4 divided by 4. So we're cancelling those out and we're just left with the 4 times 4, which we've already said is 16, that we can write on here. Okay. Question 30. Write down the exact value of cos 60 degrees. I would recommend that you learn these ones, because otherwise it's only 1 mark. You don't want to be spending too much time on it. And I don't believe that you're given these values. No, we're not given these. So if you know it, brilliant. If you don't, you can work it out. It's not, well, if you've done it before, it's not too bad. It's a good exercise to go through. So think, where can I get 60 degrees? Well, I would get 60 degrees if I had an equilateral triangle. Pretend this is equilateral. So all of the angles would be 60 degrees. And let's just say, well, it's equilateral, so all the sides are the same length. Let's say each of the sides are 2 centimetres long. Now, if I put a line straight down the middle, I've now got a right angle triangle. So instead of, this might be 2 centimetres all the way across, But this part of the triangle, this side, is only 1 centimetre because it's half. And this angle, although it was 60 degrees for all of it, half of 60 is going to be 30. So I'm going to redraw that triangle now so it looks tidier. Okay, so we've got 60 degrees, 30 degrees, right angle. We know this is 2 centimetres. We know this is 1 centimetre. We want to know what cos 60 is. Cos of this angle. Well, now you can think, this is just trigonometry. And in fact, we are given the formula for this. So if we go on the back. Now, whether they're going to continue to give these formulas or not, you want to check. But they have been given previously. So cos of cos of the angle is B over C, where B is the adjacent and C is the hypotenuse. And I'm sure you're all just saying, well, it's so ca toa. We want the ca bit. So if this is the angle we're interested in, the adjacent would be down here and the hypotenuse up here. And this would be the opposite the angle, but we're not interested in the opposite. So we want the adjacent, which is 1, divided by the hypotenuse, which is 2. So the very straightforward answer is a half, but obviously we've gone quite a long way round to do it. So it's nice if you want to be able to work it out. I say it's a good exercise to do, but it is only 1 mark. So if you can't remember it off the top of your head, feel free to try it this way, but I would suggest you do the other bits in the paper first and then see how much time you've got left to work it out this way. Question 31. It's the final question. The probability tree diagram shows the probabilities that Shayla will work at home or will work at the office on 2 days next week. Okay, so on Monday, 0.2 probability that will work at home, 0.8 work in the office, and then we've got different probabilities for Friday. Work out the probability that Shayla will work at home on Monday and work at the office on Friday. So home on Monday, office on Friday. So it's this route, only one path. So we've got the 0.2, 0.3. We're going to multiply those two together. 2 times 3 is 6. We've got 1 decimal place here and another decimal place here. So we move the decimal point once, twice. So we've got 0.06. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, add any comments, and look forward to seeing you again soon. Thank you.